Hello all. In last lecture we have seen about curve stretchings, Cartesian point. In that we have seen 2 points how to sketch Cartesian curve, symmetricity and origin. Now we will see the rest points. In that the third one is spatial point. And what is the meaning of spatial point? There are basically 2 points, multiple and ordinary. Multiple means a point through which more than one branches are passes through. For example, this point origin and this point a comma 0. For this point exactly two branches for the curve, so the word is double point, and otherwise it is called an ordinary point. Now first point in this, if a point is double point, then there are basically three types: node, cup and isolated or conjugate. The word itself says the mathematical meaning. The figure will be as node type. So in node, the two tangents are real and distinct. Distinct means different. You can see in this figure, x-axis and y-axis are the tangents for this curve, and both are real and distinct. You can check for this example, x cube plus y cube is equal to 3axy. And to check tangents, you have to equate lower degree term is equal to 0 and you will get x and y axis. In a same way, cup, here you will get two tangents as real and coincident. Another word is equal. You can check for this example, the shape is like a cup, and if you equate lower degree term is equal to 0, you will get this shape. And in isolated or conjugate, you will get imaginary tangents. For this example, if you equate lowest degree term is equal to 0, you will get imaginary tangents, and it can't be plot in 2D. So for example, you can check this. Let us take x cube plus y cube is equal to 3xy. So its shape is as like a node, and x-axis and y-axis are the tangents you can see here. Then the second example is y square into a minus x is equal to x cube. So let us take this y square into 1 minus x is equal to x cube. So yes, the shape is like a cup and x-axis are two tangents, real and distinct. Next point in this is point of intersection. That means intersection with x-axis and y-axis. And we know that to check point of intersection with x-axis, you need to put y equal to 0. For y-axis, you need to put x is equal to 0. For example, for this circle, if I take x is equal to 0, you will get y equal to plus or minus a. So the points are 0, a, minus a. If you put y is equal to 0, you will get x is equal to plus or minus a. Then the points are plus or minus a, 0. So you know that point of intersection with x-axis and y-axis. Next, if you get this type of points, then you can find tangents parallel to x-axis and y-axis, horizontal and vertical tangents. So to find tangent parallel to x-axis, you need to take slope is equal to 0. Again the known data, you need to take dy by dx is equal to 0. Then tangent parallel to y-axis, you need to take dy by dx tends to plus or minus infinity. Now to find tangent at any random point e comma 0, what you have to do, you have to take small x is equal to capital X plus a. That means you need to shift origin at e comma 0, and the same process, take lowest degree term is equal to 0 and you will get the answer. So for this example, first of all find point of intersection. So to find point of intersection with x-axis, substitute y0, you will get x0 and x is equal to 2. So one point is 0 0 and another point is 2 0. And to find point of intersection with y-axis, take x is equal to 0, you will get y0. So here we have origin and other point is 2 comma 0. So for other point you need to take small x is equal to capital X plus a, like small x is equal to x plus 2 here. Substitute it in the equation, just simplify it. So you will get y square is equal to minus x raised to 4 minus 2 capital X cube, and the lowest degree term is y square, take is equal to 0, then y will equal to 0 0. That means x-axis is the tangent at point 2 comma 0. Let us take next point. The fourth point is asymptotes. Asymptotes means tangents at infinity. So there are basically three types of asymptotes: parallel to x-axis, parallel to y-axis, and oblique. That means horizontal asymptote, vertical asymptote, and oblique asymptote. So to find horizontal asymptote, you need to take coefficient, this is the main point, coefficient of highest degree term in x only is equal to 0. To find asymptote parallel to y-axis, you need to take coefficient of highest degree term in y equal to 0. So what you can find, you will get y equal to some constant and it is tangent at infinity, so your x will be plus or minus infinity. For vertical, you will get x is equal to some constant and y will be plus or minus infinity. For example, here first of all find horizontal asymptote. So just simplify the terms and we need to take coefficient of highest degree of x. Here what is the highest degree of x? It is x only raised to 1. So just combine these two terms. It will be y square minus a square into x is equal to minus a cube. Take its coefficient, it is y square minus a square equal to 0. So you will get y square equal to a square, then y square equal to a square means square root, y equal to plus or minus a. So it is your horizontal asymptote. So you have two horizontal asymptote, y equal to a and y equal to minus. To find vertical asymptote, take highest degree coefficient of y is equal to 0. Here highest degree coefficient of y square is the highest degree. Its coefficient is x. Take x is equal to 0. So y-axis itself is a vertical asymptote. So here we have horizontal and vertical asymptote. So whenever you have horizontal and vertical asymptote, you need not to check about oblique asymptote. Oblique means neither horizontal nor vertical, and its equation will be like y equal to mx plus c. So to find oblique asymptote, we have to find y equal to mx plus c's value of m and c. Now before that, just check this: y square into x is equal to e square into x minus a. Y square into x is equal to e square into x minus 1. I'm taking here e is equal to 1. So what will you get? Yes, you can see here that y-axis is tangent at infinity, and here x-axis also can be tangent at infinity. So both are called asymptote. Now for oblique asymptote, there are basically two types: explicit function and implicit function. What is the meaning of explicit function? If you can express any of this Cartesian coordinate x in terms of y or y in terms of x, then the function is called explicit. For that you can directly find m and c, like m is equal to limit x tends to infinity y by x, and c is equal to limit x tends to infinity y minus mx. From this itself, divide by x, so you will get m, and just shift this mx, you will get c. Now for implicit, you need to check 4 steps. Implicit means whatever one variable can't express in terms of other, then the function is called implicit function. For that you need to do 4 steps. First step is what? Take x is equal to 1 and y equal to m in the implicit equation. Then in highest degree term, for example n is the highest degree term, then you will get function in terms of m. So say another function phi n of m. Then for the second term, take it as 0 and find the value of m. You will get m. Now to find c, you have to take minus phi n minus 1 of m upon phi n dash of m. What is phi n minus 1m? So you need to take one lower degree term, then this, and divide it by its derivative, and then minus, then you will get c. So you need to remember these steps, and you will get m and c in y equal to mx plus c. It is your required oblique asymptote. For example, let us take this example. Directly we are finding oblique asymptote if exists or not. So take x is equal to 1 in this and y equal to m. In the highest degree term, what is the highest degree term here? Y cube minus 6x square plus x cube. So highest degree term will be y cube plus x cube. So substitute it. So you will get m cube plus 1. Its degree is 3. So take f3 of m. Now take f3m is equal to 0. So m cube plus 1 0. So you will get this value, m equal to minus 1, and this. By delta method you will get complex numbers, complex conjugate. It is not possible for a slope. Slope is always a real number. So you have only one, m equal to minus. Now to find c, the formula is minus f2 of m upon, here it is dash, f3 dash of m. So what is the one lower degree term? Minus 6x square. Substitute x is equal to 1 in that. So it is minus of minus 6, and its derivative of m cube plus 1 is 3m square. So minus minus plus 6 by 3. So answer is 2. So you will get m minus 1 and c is 2. So by oblique asymptote y equal to mx plus c, it is equal to minus x plus 2, and your answer is x plus y equal to 2. You can check it by y cube minus 6x square plus x cube. Y cube minus 6x squared plus x cube is equal to 0. So x plus y plus 2 is your oblique asymptote. You can see here, this is the line x plus y plus 2. That's it for the today's session. We'll see more examples next time.